Okay, so let's look at a little bit of review on GCF because today we're going to be looking at factoring out the GCF. Next couple of days we're going to be looking at factoring, and the first type of factoring is factoring out the GCF. All right, so let's look at number one. We want to know what the GCF of 12 and 18 are. Essentially, we're looking for what is the largest number that divides evenly into both 12 and 18. And the way to do this is to break things up into their prime factorization. Alright, so what that means is we want to know all the prime numbers that multiply to give us 12. So the easiest way to do that is a factor tree. So we can look for any two numbers that multiply to give us 12. So for instance, 2 times 6. When you see a prime number, you circle it. So 2 is prime, it doesn't break down anymore. But 6 does. 6 breaks down into 3 times 2. Alright, neither of these break down anymore. So all the ones that we circle represent the prime factorization of 12. So 12 is 2 times 3 times 2. And you can check that. 2 times 3 is 6, times 2 is 12. So these three numbers multiply to give us 12. We want to do the same thing with 18. We want to do the prime factorization. So I'm going to do a factor tree. So 18 breaks down into 9 times 2. Alright, of these two, 2 is prime, so I don't need to break that down anymore. 9 can break down into 3 times 3. Both of those are prime as well. So 18 is 3 times 3 times 2. So the greatest common factor is going to be whatever shows up here in both lists. And we have two things that show up. We have a 2 and we have a 3. So the GCF is going to be 2 times 3 because we have both of those showing up. So the greatest common factor of 12 and 18 is 2 times 3, which is 6. So the GCF of 12 and 18 is 6. Alright, if we look at let's do number 3 and then we're going to do number 2. Number 3, 4, so when we have a variable, we just need to break down the variable as well, and I'll show you how to do that in just a second. First, let's break down 4. 4 breaks into 2 times 2. Both of those are prime. So 4 breaks down into 2 times 2, and x doesn't break down. So this is just 2 times 2 times x. Alright, let's break down 16. 16 breaks down into 2 times 8. And 2 doesn't break down anymore, so I'll circle that. 8 breaks down into 2 times 4. And this 2 doesn't break down anymore either. And then 4 breaks down into 2 times 2, and neither of those 2's break down at all. So I've got 4 2's. If you multiply 4 2's together, you get 16. So 2 times 2 times 2 times 2. Now I also have x squared, so I need to break that down. Well, what do I multiply to get x squared? Well, I multiply x times x. So this becomes x times x. So the GCF is going to be what they have in common. So if I look at the lists of what they have in common, they both have a 2 in common, they both have another 2 in common, and they both have an x in common. So the GCF is going to be 2 times 2 times x, or 4x. So the GCF of number 3 is 4x. Alright, let's do the next one. So we got 20a cubed, and 24a squared, and 16. So we got 3 of them. So we're going to have to break them all down. So 20 breaks down into 5 times 4, 5 doesn't break down anymore. 4 breaks down into 2 times 2. And neither of those break down either. So 20 breaks down into 5 times 2 times 2. And a cubed breaks down into a times a times a. Alright, next we want to break down 24. So 24 breaks down into 2 times 12. 2 doesn't break down anymore. 12 breaks down into, well, I'm going to run out of room here. Let's do it over here. So, nope, that's not going to work either. Alright, let's do it over here. 24, 2 times 12. 12 breaks down into 2 times 6. And 6 breaks down into 2 times 3. Alright, so what I have for 24 is 2 times 2 times 2 times 3. And then 16 breaks down into 4 times 4. Now, neither of these are prime, so I need to break them both down. 4 breaks down into 2 times 2. So I can circle those. Any number that you don't circle needs to be broken down. And this breaks into 2 times 2 as well. So both of those 4's needed to be broken down. It breaks down into 4 2's. So 2 times 2 times 2 times 2. Alright, so the greatest common factor, or the GCF, is going to be what they have in common. So they each have a 2 in common. This 2, and this 2. And they each have another 2 in common. This 2, and this 2. So the GCF is 2 times 2, which is 4. So the largest number that goes in all 3 of these is 4. Alright, so that's essentially what we're going to be using to help us factor out the GCF. Now, the only thing you need to keep in mind is if the first term is negative, you need to factor out a negative. So let's start with an easy one, 3x plus 3. So the first step here is to identify the GCF of the two terms. The GCF of 3x and 3 is going to be 3, because 3 doesn't break down. This is just 3 times x. And this doesn't break down. This is just 3. So what they have in common is 3. They both have a 3 in common. Oh, this is technically 3 times 1. Alright, we'll just leave it as 3 times 1. There's 3 times x, 3 times 1. So the GCF is 3. So if we want to write this in fact, if we want to factor out that 3, we want to know what's left over. So what's left over is what they don't have in common, x and 1. So it's x plus 1. Now you can check this by using the distributive property, because factoring is just the opposite of distribution. If you did this correctly, when you distribute, you should get back to 3x plus 3. So I'll distribute the 3. 3 times x is 3x, and 3 times 1 is 3. So I get back to my original problem. So this right here is the factored form. 3x plus 1 times x plus 1. Alright, the next one, x squared minus x. So x squared breaks down into x times x, and x is just x times 1, or 1 times x. So what they have in common is an x. So the GCF is x. So what I'm going to do is I'm going to bring x to the outside. I'm going to factor the x out. So that x that I highlighted in red, I'm going to factor that out. What I'm going to be left with is what's left here in blue, x minus 1. So this is the factored form, x times x minus 1. Of course, you can check this by using the distributive property. X times x is x squared, x times 1 is 1x, or just x. So it does distribute back to what we had to start with. Alright, let's look at ones that are a little bit harder. So number 3, 7x cubed minus 21x. Alright, 7 doesn't break down. 7's prime. So this is just 7 times x times x times x. It's 3 x's. 21, however, does break down. Breaks down into 3 times 7. And neither of those break down, so we can circle them. So 3 times 7. So 21 is 3 times 7, and then times x. So what they have in common is going to be the GCF. So they both have a 7 in common, and they both have an x in common. So the GCF is 7x. So I can factor the 7x out. So the 7x can get factored out. What's left over is what's not in red. So here I have x times x, so x squared, minus, pay attention to the sign, minus, and then here I only have the 3 left, so x squared minus 3. So that would be the factored form when I factor out the GCF of 7x. So I factored out the GCF of 7x, and I get 7x times x squared minus 3. Alright, number 4 has 3 terms, so all 3 of them need to be broken down. Alright, 2 doesn't get broken down, it's prime, so this is 2 times y times y times y. 4 gets broken down into 2 times 2, so 2 times 2 times y times y. And 6 gets broken down into 2 times 3, so 2 times 3 times y. Alright, the GCF is going to be what they have in common. All 3 of them have a 2 in common. All 3 of them have a y in common. So the GCF is 2y. Alright, so I'm going to factor out the 2y, and what's going to be left is the stuff that's still in blue. So here I have y squared, plus, here I have 2y, plus, and here I have 3. So this would be the problem with the GCF of 2y factored out. And of course you can check this by using the distributive property to make sure that it goes back to where we started. Alright, number 5, this is where you have to keep in mind that if the first term is a negative, you have to factor out a negative GCF. So when I start the GCF here, just know it's going to be negative because the first term is negative. Alright, so 3x is just 3 times x, and 6 breaks down into 3 times 2. So it looks like what they have in common is a 3. So my GCF is going to be negative 3. So negative 3 is what I'm going to factor out. What I have left over is x, and then this sign is going to change because I'm factoring out a negative, so it's going to change minus. Alright, so when you factor out a negative, all the signs change. Alright, this x becomes a positive x, and this 2 becomes a negative 2. So my factor is what's left over in blue, which is x minus 2. Because my 2's left over, my x is left over. So x minus 2. So my factored form with the GCF factored out, negative 3 times x minus 2. All right, so 12, we may need to use the tree to break down 12. Breaks down into 3 times 4. We can circle 3, but 4 needs to be broken down some more into 2 times 2. And then those can be circled. So 12 breaks down into 3 times 2 times 2, and x squared breaks down into x times x. And then here, that's just 3 times x. So we're looking for what's left, or we're looking for what's in common, the GCF. So they both have a 3 in common, they both have an x in common. So the GCF is 3x. Now, for this last term, both the 3 and the x are going, so remember, there is a 1 there, technically. So when we're looking for what we're left with, keep in mind that 1 is there. So 3x is what we're going to factor out. The GCF is 3x. What's left over is what's in blue. So for the first one, 2 times x. So what's left is 4x minus, and what's left here was not going to be anything, but we do have a 1 technically, so it's 1. So the factored form, 3x times 4x minus 1. All right, number 7. As long as you follow these steps that we're going through, you really can't mess this up. 8 breaks down into 4 times 2. 2 cannot be broken down, so we'll circle it. Can't circle 4, so we need to break it down into 2 times 2. So 8 breaks into 2 times 2 times 2. X squared breaks down into x times x, and then we just have a y. And then 4 breaks down into 2 times 2, and then times x, and then times y. So we're looking for what they have in common. They both have a 2 in common. They both have another 2 in common. They both have an x in common. And they both have a y in common. Okay, remember, all of these in the second we've had in common. So remember, there's a 1 here. All right, we're going to need to use that 1 because everything else is crossed off. So there is a 1 there. The GCF is everything in common, so 2 times 2 times x times y. So 4xy. So we're going to factor out the 4xy, and then what's left over for each term is what's in blue. So for the first term, it's just the 2 and the x, so 2x. For the second term, the only thing that's there is the 1, so it's minus 1. So the factored form is 4xy times 2x minus 1. This is the GCF that's been factored out. All right, thank you.